Welcome to the DIY Honda Garage channel. The specific diagnostic trouble code DTC P0977 pertains to a high circuit condition in the Shift Solenoid Valve B of the Honda CRV, manufactured between 2017 and 2022. This code suggests a potential electrical issue within the circuit rather than a mechanical malfunction within the transmission itself. The Shift Solenoid Valve B plays a critical role in regulating the transmission fluid to enable proper gear shifting. This solenoid is typically located within the transmission assembly, where it interfaces with the powertrain control module, PCM. The PCM monitors this solenoid to ensure optimal transmission performance. When this fault code is triggered, it can lead to symptoms such as harsh shifts or transmission slippage, making it crucial to address this issue promptly. The error code P0977 indicates that there's a significant problem within the circuit of the Shift Solenoid Valve B. This solenoid is designed to control the flow of transmission fluid, enabling efficient gear changes, and is crucial for smooth transmission operation. The electrical circuit associated with the solenoid can present issues such as high resistance or an open circuit, therefore affecting the solenoid's performance. The solenoid is typically situated in the transmission assembly, and its efficacy is closely monitored by the powertrain control module, PCM. If an electrical fault occurs, the PCM may detect improper voltage levels, leading to the DTC P0977 being flagged. This error does not point towards a mechanical failure in the transmission system, but rather an electrical anomaly. Several factors can contribute to triggering DTC P0977. Firstly, wiring issues such as frayed, damaged, or corroded wires can disrupt the electrical signals required for the Shift Solenoid Valve B to operate correctly. Secondly, a short circuit might occur, causing the solenoid to receive inappropriate voltage, resulting in higher resistance and flagging this error. Additionally, a faulty solenoid itself can cause circuit problems. If the internal components of the solenoid fail, it may not function as intended, leading to circuit high conditions. Therefore, thorough inspection of both the wiring and the solenoid is essential in diagnosing the root cause of the issue. Users may experience distinct symptoms when DTC P0977 is active. One common symptom includes harsh gear shifts. This condition can lead to uncomfortable driving experiences where shifts may feel abrupt or jerky. Another potential symptom is transmission slipping, whereby the gears may not engage correctly, losing power during acceleration. Additionally, drivers will notice that the DTC indicator light is illuminated on the dashboard, signaling a malfunction within the transmission's control systems. Awareness of these symptoms is vital for prompt diagnosis and repair, as they can contribute to further mechanical problems if not resolved promptly. The first troubleshooting step for DTC P0977 involves verifying the problem's presence using the Honda Diagnostic System, HDS. Begin by turning the key to the on position without starting the engine. This allows the onboard computer to process current data. Next, use the HDS to clear any existing DTCs, including P0977. Once cleared, start the engine while in park and allow it to run for at least 10 seconds. After this brief period, check the HDS again for pending or confirmed DTCs. If P0977 reappears, this indicates a persistent issue, prompting further investigation into the solenoid and its circuit. If it does not, intermittent issues or external factors may be suspected. In the second troubleshooting step, begin by turning the vehicle to the off or lock mode to ensure safety prior to any electrical testing. It's important to jump the SCS line with the HDS and wait for over a minute while doing so. This step protects the powertrain control module, PCM, from potential damage during testing. After waiting, disconnect the PCM connector C, specifically the 51-pin connector, 51P. Measuring the resistance is crucial to assess whether the Shift Solenoid Valve B is functioning correctly. Next, follow the directions to measure resistance between specific test points to determine if it falls within the expected range, which should be between 10.6 and 13.5 ohms. If the measured resistance is within this range, the solenoid is likely operational, while unexpected results may indicate other issues needing attention. The third step in troubleshooting DTC P0977 involves checking the solenoid wire harness for continuity, signifying the integrity of the connection. First, disconnect the solenoid wire harness A, which has an 8-pin connector. After disconnecting, verify continuity between two designated test points: the solenoid wire harness A, female terminal number 5, and the PCM connector C, 51P, number 19. It's critical that a good electrical path exists between these points, as a break in the circuit would cause the solenoid not to function effectively. If continuity is confirmed, proceed to the fourth step. However, if continuity is absent, repairs must focus on any identified breaks in the solenoid B wire connecting the solenoid wire harness A to the PCM. In the fourth troubleshooting step, the focus shifts to evaluating the internal resistance of Shift Solenoid Valve B itself. To begin, disconnect the 2-pin connector specifically connected to the Shift Solenoid Valve B. After isolating this component, measure the resistance between designated terminals. The male terminals of the Shift Solenoid Valve B connector number 1 and vehicle body ground. The ideal resistance range is again between 10.6 and 13.5 ohms, which indicates that the solenoid is functioning correctly. If the resistance falls within this range, further investigation should be directed towards repairing any open circuits found. Conversely, if resistance readings fall below this threshold, the solenoid is likely malfunctioning, necessitating its replacement alongside the valve body assembly to restore full functionality. Following completion of the necessary repairs associated with DTC P0977, conducting a final verification is vital to ensure that the system operates correctly. Initially, confirm that all repairs have been adequately implemented by revisiting each connection and component involved in the troubleshooting process. Next, use the HDS to clear any DTCs recorded in the PCM, as this will reset the monitoring system. After clearing the codes, proceed to test drive the vehicle under various conditions, simulating scenarios that previously triggered the fault. Monitoring the performance during this drive allows diagnosis of any persistent or newly recorded DTCs, ensuring the issue is successfully addressed. A thorough validation confirms not only correctness of repairs, but ensures your vehicle's transmission performs as intended. Implementing preventive maintenance can serve to diminish the likelihood of encountering DTC P0977 in the future. Scheduling regular checks on the transmission systems can preemptively capture issues before they escalate. It's also advisable to visually inspect wiring associated with the Shift Solenoid Valve B and other related components to identify early signs of wear or damage. Regular updates of the vehicle's software and firmware can also help maintain optimal communication between components. Making it a habit to take your vehicle to authorized service centers for software updates and inspections can contribute to the overall longevity and reliability of the transmission system. In summary, understanding DTC P0977, which indicates a high circuit condition in the Shift Solenoid Valve B, is crucial for effective diagnosis and repair in Honda CRV models from 2017 to 2022. The troubleshooting steps outlined allow for an organized approach to diagnosing electrical issues related to this component. By thoroughly following each step and confirming repairs, technicians can address not only the immediate problem, but also contribute to the vehicle's long-term reliability. Implementing preventive maintenance strategies can significantly enhance the overall health of your vehicle and help prevent future occurrences of similar DTCs. Ultimately, proactive management of electrical circuits and components can lead to more satisfied driving experiences. Please like and subscribe to the channel. See you next time.